Hello everyone, uh, welcome to my channel. Today we will be solving the fourth problem of Leetcode, that is median of two sorted arrays. It is categorized as a hard problem and the problem statement is very simple. That is, we are given two sorted arrays nums1 and nums2. We need to find the median of both the arrays combined in O of log of m plus n time. Now, a very brute force approach to this would be to concatenate one, not exactly concatenate, but merge two arrays by using two pointers and keep them in a third array. The third array will be the sorted array and find return the median of the third array. But that will take O of m plus n time, assuming the size of this is m and the size of this is n, and we want to reduce the time complexity. It can be done in O of log of m plus n, and I'll show you how to do that. So let's get into it. So guys, let's see the explanation and the solution to the problem, and I'll explain you step by step how to approach this to the solution to this problem. I won't just explain the solution, but also how to get to the solution so that you get a better grasp of the solution. All right. So basically, these are the two arrays. One of them is 357, the other is 1268. Now we need to find the median of both of them once they are merged and sorted. So uh, once we have the, let's use the brute force approach. So in the brute force approach, after sorting them, it would be 1 2 3 5 6 and 7 and 8. Yeah, and since it is odd number, so the middle element will be the median, and we need to get 5. All right, so what we are doing, Basically, let's see in how many ways can we partition the array 3. All right, I'll tell you why I'm doing that. Just bear with me a little bit. So let's say we partition 3, like array A from here. So we have left side empty and right side 357. So basically we have an empty set over here, and right side we have 3, 5 and 7. Sorry, it's 3. And when we have that, now what I need to do is I need to find the partition part in array B as well. Okay, now the definition of the median says it divides the array into equal halves. All right, so if they are sorted. So if there are three elements on the right, there should be at least three elements on the left, right? So based on the median, we will be dividing the array into two equal halves. So the total number of elements in the array is 6 plus 1, 7, right? So each side of the array should have at least three elements. But since it's an odd one, the left side should have four elements. All right. So since we have already taken three elements for the right side, now we need to find where should we place the partition in B such that if we divide the array B into left and right halves and merge it with the above, then we have equal number of elements on both the sides. So it's 1268, right? So let's say if we take a partition here after 8, so what do we have here? 1, 2, 6 and 8, and then we have empty. Okay, so this is how we divide based on, I'm just giving an example. This is not the algorithm, all right? If we divide the array such that the first partition is here, then the partition place for B can be obtained by total size of both the arrays, that is 7 plus 1 8 divided by 2 minus partition of this place. And I'll just show you the code where it's a okay. So first of all, we obtain the partition for A, right? So the partition for A is initially 0. It can be either 0th place, that means it contains 0 elements to the left. See, this is the 0 elements to the left. That's why 0th place. Then we have 1, in which case it divides into 3 and 5, 7. In that case, we have one element to the left and we can divide it into, next we have 3, 5, 7. That's another partition, and next we can have all these elements to the left and empty in the right, right? There are four ways to divide this array A or partition this array A. Now in this particular formation of partition, since we have already decided that 0th location will be the place for A to be partitioned, we need to calculate B's partition location by using this formula: total plus 1 divided by 2 minus partition location of A. All right. So partition location of A is 0. You can see from here. All right. Since it is 0 and total is the size of both the arrays, and due to that we have total number as 7, and 7 plus 1 is 8, right? And 8 divided by 2 is 4, and 4 minus the partition place of A. So 4 minus 0 is 4. So we will partition it from fourth location. All right. So this is how it is partitioned if it were to be partitioned here. Now let me give you another example of how another partition might look like. Let's say I'm partitioning it here. This place would be 0, 1, 2. I'm partitioning it at second location. So what will happen is on the left we will have 3 comma 5, and in the right we'll have 7. And since we have used 2 as the partition place for A, and using that formula we will calculate total plus 1 8 divided by 2 4. 4 minus 2 is 2. So it will partition it here in 2. So what will happen is this 6 and 8 will move towards the right side. All right. and this will be the final partition of the left side and the right side. All right, and let's just check the small thing, right? Let's say uh, in this particular case 5 is less than 6 and 2 is less than 7. Now I'm getting to the solution, so pay attention carefully. 5 is less than 6 and 2 is less than 7, and we already know since each of the array is sorted, so 2 is less than 6 and 5 is also less than 7. So what we can basically say is right part is self-contained, so is left part. So basically we have 4 elements in the left and 3 elements in the right, and the maximum of this left section would be the answer since it's an odd number. Had it been an even number, in that case we would have to take uh, we have to calculate the average of middle two elements. We will get to how do we calculate the average of middle two element, but before that I just want to make sure you understand why we are doing the partition. We are doing the partition for A and then figuring out where to partition B based on that formula, because the median divides the merged array into two equal segments. So that property can be used to form that particular formula, and that formula can be used to figure out where to partition B. So once we figure out where to partition A, then we figure out where to partition B, then we can check this condition. If this is less than this and this is less than this, what that means is we have found the perfect middle spot which will divide that array into two equal halves. Once we have found that perfect middle spot, we can calculate the median very easily. All right, so this is what the partition does. But now how do we go about solving the problem, actual problem? So what we will do is, since we have 4 places for this particular case, 0, 1, 2 and 3, so total 4, right? So we can partition it in 4 ways from 0 till the size of this. So we will run a binary search with 0th as the lowest and the size of this as the highest. And for each binary iteration, if uh, basically if this condition is satisfied such that the one array's maximum is less than this and this is greater than this, all right, if this is satisfied, then we have found the perfect middle element. Now if that is not the case, let's say we have partitioned it here. All right, let's say we have partitioned it here, and since we have taken one element from here, it will reduce one element here, and in this particular case we can check that 3 is less than 8, one condition is satisfied, but 6 is less than 5 is not satisfied, right? So what that means is, uh, to satisfy this condition we will have to move this towards the right. All right, so we will move this towards the right, and since we are moving this towards the right, we will move this towards the left. And this is one case, and let's say if we were in some other case, such as it was here the partition, and since that was there, and this partition would be here, and in this particular case you can check that 7 is uh, less than 2 is false, right? So it's already failing. But here also you can see the edge case, and for handling this edge case where there is no element, we have in the code we have handled it gracefully by using this int min and int max. And when we do that, when we do that, it handles the edge case very smoothly. So in this particular case, when 7 is larger than the right side, it is in the left of the first array, remember that. What we need to do is we need to move this towards the left. So we'll move this towards the left here, and since we are moving it towards the left here, the formulas will give a new middle for the bottom one, and that will give this is how we approach. But what I was doing right now was moving only one step either towards left or towards right of A. But instead of doing that, we can do is have a binary search on the places where A can be partitioned, and the time complexity for that will be um log of size of A. and A is the size. A size is minimum. All right, so we always take A size as minimum, and I'll tell you how to handle if A size is larger than B. But if we are taking assuming A size is minimum, and we are doing the partition using binary search, and using this we will arrive at a location where it is dividing both the sides into separate segments, such that these two elements are always greater than this and this. So this is A1, this is A2, and this is B1, this is B2. So A1 less than uh, okay, I'll just write it down for you to. So A1 will be the largest element in the left, and A2 will be smallest in the array A of that partition, and similar for B1 and B2. So until this condition is satisfied, the condition is A1 less than B2, because we always know in a sorted array A1 is less than A2 and B1 is less than B2, and B1 less than A2. If this condition is satisfied, we found the middle element. Now, based on whether it is even or odd, we need to return the middle element or average of two elements. All right. Okay. So now in this particular case, I have explained to you how to handle if it is a middle element. If it is a middle element, what we need to do, like if it is an odd number of the total size is odd, what we need to do is basically return the maximum of A1 or B1, because that will the middle element. Once we sort this, since we are having more number of elements on the left, once we sort this, the maximum of this will be the median. But let's say that's not the case, right? We have some random x1, x2, and then y1, y2. Okay, these are the two elements that are closest to this partition, and we want to find out um the average of the middle two of these two. All right, so we need to merge this and sort them. Now, after merging this, what will be the minimum element? Tell me. It's very simple, right? See, x1 is less than x2, so x2 cannot be the minimum, right? And similarly y1 is less than y2, so y2 cannot be the minimum. So the minimum should be minimum of x1 comma x2. Now I'm sorting them. All right, and let's forget the middle two element because we don't know what that is. And okay, tell me, what is the biggest number out of all of these four? X2 and y2, right? Maximum of these two, right? Because x1 is less than x2 in a sorted array and y1 is less than y2, so we can write this as maximum of x2 comma y2. All right, so now we have taken a very interesting approach. See, we have found the minimum in out of this four, and we have found the maximum. So whatever is remaining out of this four is the middle two elements. Pretty obvious, right? So if we have taken minimum of these two, what is remaining is maximum of these two. All right. See, it's pretty simple. Since we have taken minimum of this, the remaining is maximum of this. And now since we have taken maximum of this, the remaining is minimum of x2, y2. Sorry, it's y1. My bad, my bad, my bad, bad, bad. Okay, so see, since these two are minimum, x1 and y1, the minimum of this will be the minimum of all the four, and these two are largest, then the maximum of these two will be the largest. And since we are already filling the all the four, the first and the last place, the middle two elements can be found by whatever is remaining. So if minimum is taken out, the maximum will be remaining of the two, and if maximum is taken out from these two, the minimum will be the remaining, right? And we can find the median by using the average of these two. All right, so the average of these two will be the sum of these two, um, the sum of these two and divided by 2, and let's just put 2.0 so that the answer is double. Okay, um, so that's the solution and that's the logic behind it. And let's go to the code, and I'll give you a brief walkthrough about through the code. All right. So here is the code. Okay, so first line of code is like I'm checking the size of the second array. If it's greater, if it's less than the first, then I'm just calling the same function in reversed order of A and B. So what this does is A is always smaller than or equal to B. All right, so this particular line makes a smaller than or equal to b in terms of size. Now if there is the size of a is 0, what that means is we have to return only the median in b, since b is the only remaining uh, array. And if b is the remaining array, we can return the median of b by simply checking whether it is odd. If it's odd, then we can return this. If it's even, then we can return the average of middle two elements by using this formula. All right, now we have already checked a size is not equal to 0, and if b size is 0, what that means is even a is 0, so there are no elements in both the arrays. In that case, we can return 0. All right, and that is one other edge case. And after that, we come to our formula of binary search. So low is 0, high is a dot size, total is the total sum of both the sizes of both the arrays, and the mid a will be the middle element in a where partition will occur, and we'll use this formula to calculate that. We'll use low less than equal to high because we are incrementing and decrementing as well. And mid b will be calculated using this formula, and this is just to handle the edge case where the partition is at either edge of the array of either a or b. Let's say partitioning at 0th location or partitioning at a dot size location, for handling such cases. Now we are assigning based on if it is a actual location, like we cannot have 0 minus 1, a of 0 minus 1. So we are just handling edge cases and assigning them locations. And this is what I said about moving either like this is the condition that needs to be satisfied for it to be considered merged, like sorted, and we found the middle element. All right, this is the particular condition. And if a1 dot size is greater than b2, I have explained this previously, then high is equal to mid a minus 1. Instead of just like so here I could have done high minus 1, but that would have a time complexity of O of n. Instead, we are using binary search, so mid a minus 1 will have a binary effect since we are decreasing after each iteration by half. All right, since mid is near the half. And similar for this is moving towards left and this is moving towards right, and this is the binary search, and that's the solution. Thanks a lot guys for watching this video. To be honest, I couldn't solve this question. I had a very different approach, and though my approach was correct, I wasn't able to implement it because a little bit of fuzziness towards the end of the logic, and due to that, you have seen so many wrong answers of mine that I tried before coding the solution up. And this was just the euphoria moment where I could solve it. And to be frank, the online tutorials that I followed was only of Ravindra Babu. I will link it in the description for you guys to watch if you were not able to get a grasp of the solution with my explanation. He has much better explanation than me, and I'm pretty sure you'll be able to clear your doubts. Thanks again for watching, guys. Please do like and subscribe if you feel like. Thanks a ton. Bye. See you again.